Hello, you're welcome back to the part 2 of our thyroid cancer recurrence prediction series. I'm so glad you are here. In our last video, we loaded our data set, checked for missing values, removed duplicates, and set up our beautiful color scheme. But for today, we are diving into one of the most important parts of any machine learning project, which is exploratory data analysis. All right, so just make sure everything is well loaded up and then run the entire page. Let us start by visualizing gender distribution. I'll type print gender distribution and then print open parentheses data square bracket gender. Then outside the square bracket I will type dot value count and then open parentheses. And then next I'll also print the recurrence by gender and then also print what you're gonna get by retrieving the gender by recurrence data using this syntax. You might be wondering, why do we care about gender? Well, in thyroid cancer research, we know that thyroid cancer is actually more common in women than in men. And here you could see the recurrence in women is like 3 times that seen in men. Let's move on to creating visuals for the distribution by gender. PLT stands for the matplotlib library dot figure and then assign the size of our figure using 8 by 5. Then we'll create a count plot. So we declare AX equals to SNS. SNS stands for Seaborn dot count plot. And then we assign the parameter X equals to gender in quotes. We are doing this because we want the plots to be in the form of horizontal bars. That is why we said Y instead of X. Next, we're going to add titles and labels to our charts, just making them more descriptive. Using the syntax, which is ax.set underscore title, open your bracket, and then inside the bracket, gender distribution, and then assign a font size. We're going to assign a font size of 12 to 8. And then next, we assign the Y label, which is the name for the Y axis of our chart using a font size of 10. Next, we do ax.set s label, just as you predicted correctly, count, which is what we're going to be calling our x-axis. We're going to show this plot by typing plt.show and then running it. There goes the beautiful plot with the assigned you, which is recurrence. Next, we'll be adding a legend. Actually, the legend is already being shown by default, but we're gonna be showing the syntax for how to add a legend. In this, we're gonna call our legend or name our legend record, and then get it located on the right bottom corner of the plot. Apologies for what the AI is doing currently. It's suggesting a code that I wouldn't want to use. So let's re-edit. So we're gonna title it as record to be located at the lower right end. Okay, so let's clean up the appearance. So firstly, I'm going to show you the syntax for taking out some of those ticks you see on the x-axis as well as the y-axis. So I'll use ax.set sticks, open parentheses, and then just an empty square bracket. You see at the lower end, the ticks on the x disappeared, and you could also change that to you can change x ticks to y ticks, and then get the labels on the y-axis to disappear. That is if need be, but we're going to comment that out. So let's focus on taking out the spines. So let's do ax.spine, and then at the top we'll do dot set visible to false. At the right, set visible to false, and then also at the bottom, set visible to false. Then let's retain those at the right by setting it to true. So let's run it and see the changes. You see, we're able to like clean up the margins, but let's just make it a bit more colorful by setting the face color to ash f6 f5 f5, so that we can sorry, that should be a string. The color code should be in a string. So this gives you some form of better visualization for what the background looks like. I just hope you are coding along. It's much better to code along so that you could learn much faster. We have a very nice chart here showing you how the males and the females, those that add recurrence and those that didn't have recurrence, looks like, and the count. Let's move further to explore more around the gender distribution as it relates to recurrence. So let's calculate recurrence percentages, right, by gender. So let's say gender underscore recurrence equals data dot group by, open parentheses, gender, then use lambda x column, open bracket x equals string x, close parentheses, dot sum, open parentheses, divided by the length of x, then multiply by 100, expressing this as a percentage. So we're going to print a line of text showing recurrence percentage by gender colon. Then finally we'll print the gender recurrence just as we've assigned it above, and you see what looks like should I say, more like a table, yeah, being returned, showing us that the percentage of recurrence in males is about three times that of recurrence in females. So now let's move on to the next data we want to explore. Let's explore the relationship between smoking and recurrence. So let's try something else. Let's use the text area to rename some of the sessions on this tutorial. So let's call this visualizing the relationship between gender and recurrence. And then let's make it bold by text. Okay. So let's go down and also add to this session. Clean that off, click on text, paste, and then bold. So now, just like we did before, we want to check the data first. So let's print just like a line of text saying smoking distribution, colon, and then print data, open square bracket, smoking, outside the square bracket dot values count, open parentheses. This is just counting the total amount of smokers or smoking session or thereabout. So print the next line saying recurrence by smoking. Oh, sorry, let's name this as smoking versus recurrence cross table. All right, so yeah, I want to print PD. PD stands for pandas dot cross table, open parenthesis data, square brackets, and then smoking as a string. Outside of that, comma, then data of x of yeah, we are going to retrieve the record column of the data and then assign margins to be true. Run this. Perfect. Now we can see exactly how many smokers had recurrence and how many non-smokers had recurrence and the totals. Now let's visualize this. And there's something really cool because we are following a consistent pattern and most of this code will look almost identical to our gender plot. This is the beauty of good coding practice. You create a template that works, then you reuse it. Ax equals sns dot countplots, open parentheses, y equals quote smoking close quote. Notice that only change here is the column name, and then u equals record. Okay, and then make sure inside the color scheme then the width is 0.4. Then as dot set title, give it a title, give it assign the y label, the s label. Okay, then let's do ax dot bar. So let's add this line of code. Is new. You've not seen this before, and let's see what's gonna add to our chart. Assign legend. Let's do lower right for now. Then let's take care of the spines. Take out the top, the right, the bottom, and then Let's keep the left. Then set face color. So run this. Sorry, there's an error. What is the error? Oh, okay. We didn't assign equal to. Yeah. So that is where you get the uh, bar labels by putting the totals along the lines of the bar. So with this, I can actually set off or take off the X ticks. So take it off by assigning an empty square bracket. Yeah. Beautiful. So now we have our smoking versus recurrence plot. So let's calculate the actual recurrence rates to make this more meaningful. So we are going to use proportions for that. Recurrence rate by smoking status. So smoking stats equals data dot group by open parenthesis code smoking close bracket close parenthesis dot agg aggregate open parenthesis. So let's say record close quote comma lambda s colon open parenthesis x double equals quote yes close quotes close parenthesis dot sum open and close parenthesis and close parenthesis. So the lambda function here is counting how many yes values we have in the record column. The lambda function is just a small anonymous function, so you don't have to worry so much about it. Just copy and paste what you see. So this calculates the percentage, and we are dividing the number of recurrence by the total number of patients and multiplying by 100 to get a percentage and rounding it off to 2. All right, so print open parenthesis, then smoking impacts analysis column. So print open parenthesis smoking stats close parenthesis. So running this, excellent. So now we see the exact recurrence rate for smokers versus non-smokers. This gives us concrete numbers to work with when interpreting our visualizations. All right. You see the rates for both the smokers and non-smokers. All right. We've now created two complete visualizations together, which is visualization for gender and smoking. You've learned the syntax, you understand the reason behind most of the lines of codes, and you've also seen the patterns we are following. So the next stage is where you need to task yourself. I want us to take this simple text, pause the video right now, and then try to produce visualizations for stage and risk on your own. Just follow the pattern we've used in time past, but use vertical bars for stage, and then for the risks, use horizontal bars. This is just to make it align with the solution I'll be providing after the test session. So pause the video and start. Good job. Welcome back. Assuming you've created your stage and risk visualizations. Now, let me show you how I did it. I'm going to speed through this code since you've already written it yourself. If you want to compare your code line by line with mine, just slow down the playback speed. Click on the gear icon and choose 0.25x or 0.5x. Excellent. I hope you did well in the personal attempts. But if you didn't do well, that's fine. You can just check back the or look into the solutions provided and see the gap between what I did and what your code is looking like. It's always good to debug. Debugging teaches you much more than you ever can imagine. All right. So look into it. Make sure you use the right casing. If any word is capitalized, make sure you use it correctly that way, especially when you are referring to the data you're working with. All right. Then check your parentheses, your brackets, the quotes, the commas, and every other thing that might make your code break. Okay. So the next session is going to be more like a bonus session. We are just doing a summary of all we've done to bring everything together. But just like before, I'm going to speed through the video. Okay. In this session, I'm going to be creating a nested loop to go over the variables and then create some form of a summary table for us for both the gender, smoking, stage, and risk. All right. In case you are worried about the explanations or how to interpret these tables and the plots, don't worry, I'm going to be making a video to address that at the end of this series. Excellent work today. We've come to the end of our first exploratory data analysis video. In this video, we're able to explore four categorical features through professional visualizations. We learned the syntax for creating count plots with Seaborn, when to use horizontal versus vertical bars, how to use the U parameter to split by our target variable, and also we added value labels, and also we learned how to clean up our plots for a cleaner appearance. These skills are highly valuable, and we're going to be improving on this in our next video, where we are going to explore other forms of visualizations using our age data and the rest in our data set. We are going to use different visualization techniques such as kernel density plots, bus plot, histograms with KDE curves and all. So if you found this tutorial valuable, please hit the like button